This is the OCR GCSE 91 Maths Foundation Paper 3 from the November 2018 series, and this paper is a calculator paper. Question number 1. In a survey, people were asked to choose their favourite type of pizza. The pictogram shows some of the results. 8 people chose margherita. We've got this key which represents a certain number of people, and we have to complete the key. Well, for margherita, we have a total of 8. And therefore, we have 2 full circles which equal 8. One of those circles is equal to 4. So, we have this full circle which represents 4 people. Part B, how many people chose pepperoni? For pepperoni, we have 4 plus 4 plus 4 plus 2, and if I add all these together, we get 14. So, 14 people chose pepperoni. Part C, there were 36 people in the survey. All of these people chose one of the pizzas in the pictogram. Complete the pictogram for veggie. For Napolitana, we have 4 plus 2, which gives 6. Veggie is what we are finding. For Hawaiian, we have 4. Therefore, for veggie, we have 36 people in total. We subtract the 8 for margherita. Then we subtract 14 for pepperoni. Then we subtract the 6 for the Napolitana pizza. Then we subtract the 4 for a Hawaiian pizza, and if we work this out, we get a total of 4. So here we have the completed pictogram. We have 4 for veggie. Question 2. Work out 5 multiplied by 2 plus 4. Well, what this is equal to is 5 multiplied by, and here the 2 plus 4 is 6. So we have 5 multiplied by 6, which is equal to 30. Question 3, Part A, write 3/8 as a decimal. If we key in 3/8 into our calculator and then press S to D, we get 0.375. Part B, write 42% as a fraction. Give your answer in its simplest form. Percent means out of 100. So we have 42 out of 100. And if I work out what this is equal to, we have 21 over 50. Question 4. Tia thinks of a number. She finds the square root and subtracts 4. Her answer is 1. What number is she thinking of? Let's begin by letting x equal the number that Tia thinks of. The first thing she does with this number x is square roots the number. Then she subtracts 4. The answer she gets is 1. We need to find out what x is. If I add 4 to both sides, we end up with square root x equals 5. And now if we square both sides, what we end up with is x equals 5 squared, which is 25. Question number 5. A fair spinner has 5 sides. Each side is labelled A or B. This diagram shows the probability scale. The arrow shows the probability that the spinner lands on an A. Part A, circle the word that best describes this probability. Well, here we have an even chance. Anything closer to 1 is likely, anything closer to 0 is unlikely. So in this case, we have unlikely. Part B, here is the spinner with 2 sides labelled. We've got A and B. We have to label the other sides with A or B to give the correct probability of landing on an A. Well, what is the probability of landing on an A? We've got 0.4. The probability of landing on A is equal to 0.4. What is 0.4? That's 2 out of 5. So we have 2 A's out of 5. So we have an A here, an A here. We've got 2 of those A's. The rest are B's. So we have 2 A's and 3 B's. Question number 6. We have to write the following in order of size, starting with the smallest. We've got 0.41, 0.403, 0.438 and 0.4374. Well, here we've got 4 decimal places, so it makes sense for us to write each of these to 4 decimal places. So we've got 0.4100, 0.4030, 0.4380, and we've also got this 0.4374. So let's order these from the smallest to the largest. Here is the smallest, followed by this, followed by this, followed by this. So we've got the 0.43, followed by the 0.41, followed by the 0.4375, followed by the 0.438. Question number 7, part A. Show the inequality x is greater than 3 on this number line. Here is the inequality represented on a number line. Part B, simplify 4a plus 3c plus 7a, subtract 5c. Well, we've got the 4a plus the 7a, which gives a total of 11a, and then we've got the 3c, subtract the 5c, which gives negative 2c. So we have 11a subtract 2c. Question part C. Solve 2x over 3 equals 4. If I multiply both sides by 3, then what we are left with on the left hand side is 2x, and on the right hand side 4 times 3 is 12. If I now divide both sides by 2, what we will be left with is x equals 6. Question number 8. This table shows the ticket price for each person to visit a zoo in winter. We've got an adult aged 18 or over cost £18. A child aged 3 to 17 costs £14. A child aged 3 or below is free. Part A. A family of 2 adults, 1 child aged 8 and 1 child aged 1 visit the zoo in winter. What is the total cost of the tickets? So to work out the total cost, we have 2 adults, so that is 2 times by £18. Then we also have a child who's aged 8. That costs £14. And then we have a child who's aged 1. That's free. So that's £0. And if we work out what this is equal to, we get £50. So the cost then is £50. Part B, in summer the zoo increases the prices. An adult ticket increases by 20%, a child ticket increases by 15%. How much more does it cost the family to visit in the summer than in the winter? So we increase the adult ticket by 20%, so we need to multiply this 18 by 1.12. And if I work this out, 18 times by 1.20 is £21.60. So the new adult price is £21.60. Then we know that the child ticket increases by 15%, so I need to multiply this child ticket by 1.15. So if I do that, I have 14 times by 1.15, which is £16.10. So for the new cost, that's equal to, well, I've got 2 times by the new adult prices, so I've got 2 times by £21.60, and then I add on to this the new price of the child who is aged 8, so that is £16.10. And then the child who is 1, that's free, so I need to add on £0. And if I work out what this is equal to, I have 2 times £21.60 plus £16.10, so I get £59.30. So therefore, I've got £59.30, subtract the original £15, so that's equal to £9.30. So it costs £9.30 more than in summer than in winter. Question number 9. Nisha is going to visit 2 of these places, the London Eye, Buckingham Palace, Tower of London, British Museum. Part A, list all the combinations of these places that she can visit. One combination is already shown in the table, so we have LE, BP. We could also have LE and TL. We could also have LE and BM. Then we could have BP and TL, because BP and LE are already done, so we have BP and TL. Then we have BP being combined with BM. And then we also have the TL being combined with BM. So these are all of the combinations. Part B, what fraction of the combinations include the London Eye? So let's see which include the London Eye. We've got 1, 2, 3 out of a possible 6. So we have 3 out of 6, which is equal to 1/2. So we have 1/2. Question number 10. Here are 2 identical tiles. Part A, sketch two quadrilaterals that can be made by joining the tiles. Write the mathematical name of each quadrilateral. Well, we've got this triangle, and if I add another triangle like this, what we end up with is a rectangle. Another thing we could do is take this triangle and add it to this triangle in this way, leaving us with a parallelogram. Part B, the two tiles can also be joined to make two triangles. Work out the interior angles of each triangle. So we've got two possible triangles as we see here. Now if we take a look at the angles we have, we've got this 60 degrees and we've also got this 30 degrees. So we've got a 30 here, a 30 here, and here we've got two 60s. So this angle is 120 degrees. And then we've got the 30 degrees here and the 30 degrees here. Alternatively, we've got a 30 here and a 30 here, so this angle is 60. And then what we've got is a 60 here. And we've also got a 60 here. Question number 11. Jill uses the formula h equals 2fg. We have to find the value of h when f is 1 and g is 3. So we have f is 1 and g is 3. So we have h equals 2 times by f, which is 1, multiplied by g, which is 3. And if I work out what this is equal to, I get 6. Part B, find the value of g when h is 18 and f is 6. So we have this time h is 18 and we have f, which is 6. So I have 18, which is what h is equal to, and this is equal to 2 times by f, which is 6, multiplied by g. So we have 18 equals 12g, and if I divide both sides by 12, you will find 1.5 equals g. So g is 1.5. Question 12. Fill in each missing number. Part A, I've got 0.36 times 20 equals something times 10. Well, if I halve the 20, I get 10, which means I need to double the 0.36 to get 0.72. So I've got 0.72 times 10 is the same as 0.36 times 20. Part B, I've got 14 divided by 50 equals something divided by 100. Well, 50 is half of 100, and 28 is double 14. So 14 divided by 50 is the same as 28 divided by 100. Question 13. Part A. We have to work out 2 to the power of 4. If I type this into my calculator, 2 to the power of 4 is 16. So we have 16. Part B. Find the value of n. We have 100 equals 4 times by 5 to the n. So if I divide both sides of this equation by 4, I have 25 equals 5 to the power of n. Now 25 is the same as 5 squared, so 5 squared is 5 to the power of n, and clearly then you can see n is 2. Question number 14. 30 people choose their favourite sport. Mark wants to show their choices in a pie chart. 4 of the people choose tennis. We have to work out the angle of the sector for tennis. Well, out of 30 people, how many choose tennis? That's 4. So 4 out of 30 choose tennis. Now what we need to do is find the equivalent angle of this. So for the angle, we would have to multiply this fraction by 360. So I've got 4 over 30 multiplied by 360, which is 48. So we have 48 degrees. Question number 15. Use ruler and compass only. Construct the perpendicular bisector of FG. First thing we need to do is grab our compass and make sure that the distance between the pencil and the pointy bit is more than half this distance. Put the pointy bit at one end, and then what we need to do is draw an arc like so, maintaining the same length, pointy bit at the other end, and then draw another arc like so. Then we need to join this point to this point, and we do that using a ruler like so. So here is the perpendicular bisector. Question number 16. In a dance competition, 2 judges each award scores out of 30. The scatter diagram shows the scores awarded to the first 10 dancers. Part A. Here are the scores for the next 2 dancers. Plot the scores on the scatter diagram. So we've got 21 and 7. So that is over here. Then we've got 18 and 8. So 18 and 8 is over here. So those are the scores plotted. Then for part B, dancers who are awarded a score of more than 20 by both judges receive a medal. For the 12 dancers, express the ratio of medal winners to non-medal winners in its simplest form. So we want more than 20. So how many are more than 20 by both judges? Well, we've got 1, 2, 3. So we've got medal to non-medal, so we've got 3 who receive a medal out of 12, which means the number who do not receive a medal is 9. And if I simplify this, I get 1 to 3 as my ratio. Part C. This chart shows the types of dance performed by the 12 dancers. 3 performed a street dance, 8 performed a jazz dance, and 1 performed a tap dance. Why is this diagram misleading? Well, it's tilted. In other words, it's seen from an angle, so that's why it's misleading. Question 17. The police record the speed of vehicles passing a speed checkpoint. The speeds are recorded in the table below. So we've got the speed and the vehicles. Part A, calculate an estimate of the mean speed of the vehicles. The first thing we need to do is find the midpoint of the speeds. Midpoint of 0 and 20 is 10. Midpoint of 20 and 40 is 30. Midpoint of 40 and 50 is 45. Midpoint of 50 and 60 is 55. Midpoint of 60 and 80 is 70. What we now need to do is multiply the frequency, which is the number of miracles, by the midpoint. 5 times 10 is 50. 8 times 30 is 240. 37 times 45 is 1665. 47 times 55 is 2585. Then we have 3 times by 70, which is 210. Let's add all together the number of vehicles. 5 plus 8 plus 37 plus 47 plus 3 is 100. So we have 100 for the total number of vehicles. And if I add together the frequency times the midpoint, 50 plus 240 plus 1665 plus 2585 plus 210, that's 4750. So therefore, for the mean, that's equal to 4750 divided by 100, and if I work this out, I get 47.5. So we have 47.5 miles per hour. Part B, explain why it is not possible to use the information from this table to calculate the exact value of the mean speed. The exact speed for each vehicle is not recorded. Question number 18. The diagram shows a square, a regular hexagon and part of another regular polygon meeting at the point P. Part A shows that the size of one interior angle of a regular hexagon is 120 degrees. The first thing we can do is find out the exterior angle of the hexagon. That is this angle here. To find out this exterior angle, we need to do 360 divided by 6, which is 60 degrees. So we have 60 degrees for our exterior angle. For the interior angle, that's this angle here, that's equal to 180. Subtract this exterior angle of 60 because we've got angles on a straight line. That's equal to 120 degrees. So that is also this angle here. Part B, find the number of sides of the other regular polygon. The first thing we can do is use the fact that angles around a point sum to 360. So we've got this 120, and we've also got this angle, and we can find this missing angle here. We'll call it x. So we have the angle x plus the 120 plus the 90 degrees, which is the square. This is all equal to 360. So we have x plus 100, 210 equals 360, which means x is equal to 150 degrees. So the number of sides we can determine as follows. We know what the interior angle is. We can find the exterior angle, which is this. This exterior angle we'll call y. That's equal to 180 subtract this 150, which is equal to 30. So we have 30 degrees for the exterior angle. So to determine the number of sides, n, we need to do 360 divided by this 30, giving us 12. So we have 12 sides. Question number 19, part A. This graph shows part of a straight line. You have to write down the y-intercept. The y-intercept is where it crosses the y-axis. That's at this point 3. So the y-intercept is 3. Next, for part B, we've got this graph here. We have to find the gradient. The gradient is change in y over the change in x. So the change in y, that's 1. The change in x is 2. And therefore, for the gradient is equal to 1 over 2, which is 0.5. So the gradient is 0.5, or we could just write a half. This line is continued to the right. Will the line pass through the point 200, 102? Show how you decide. Well, for this, we need to find out what the equation of the line is. The y-intercept is 1. So, the equation of the line, that is y equals 0.5x plus 1, and this 1 is the y-intercept, and the gradient is this 0.5. Now if I consider what happens when x is 200, I've got y equals 0.5 multiplied by 200 plus 1. So we end up with 101. And clearly, this does not equal the 102. So does this line pass through the point 200 to 102? No, it doesn't. Question number 20. A bee flies from its hive to a flower at a constant speed of 7.5 meters per second for 10 seconds. The bee then takes 15 seconds to fly back to the hive. Assume the bee always lies in a straight line. Part A, ignoring the time spent at the flower, work out the overall average speed of the bee in its flight from the hive to the flower and back. So, we have over here the beehive. We'll call it H. And then we've got a flower. We've got the distance to the flower from the hive, which is the same as the distance from the flower to the hive. So, the distance to and from the hive, we have 7.5 meters per second multiplied by 10 seconds. And what this gives us is 75 meters, which means we have 75 meters from the hive to the flower, and 75 meters from the flower to the hive. Which means then the overall distance is 75 plus another 75, which is equal to 150 meters. The total time, we've got 10 seconds from the hive to the flower, being added to the 15 seconds from the flower to the hive, and that is an overall of 25 seconds. So therefore, for the average speed, we've got 150 meters divided by 25 seconds, which is equal to 6 meters per second. If the bee is not assumed to fly in a straight line, how might your answer be affected? Well, the distance may increase, so the average speed may also increase. Question number 21. Here is a right angle triangle, and we have to use trigonometry to work out the value of x. Well, we've got the opposite. We've got the hypotenuse. What connects those is sine. So therefore we have the sine of 20 degrees equals opposite, which is x, divided by the hypotenuse, 10.2, which means x equals the 10.2 multiplied by sine of 20, which means x is equal to, well, here I've got 10.2 times by the sine of 20, which is equal to 3.488, etc. So I've got 3.49 given to 3 significant figures. Question 22. A newborn baby has an approximate mass of 3.5 kilograms. A human cell has an approximate mass of 2.7 times 10 to the negative 11 grams. Use these values to estimate the number of human cells in a newborn baby. Give your answer in standard form correct to 2 significant figures. Well, here we've got grams, here we've got kilograms. We need to make sure that the units are the same. So to go from kilograms to grams, I need to multiply by 1000. So the 3.5 kilograms is the same as 3,500 grams. So therefore, for us to work out the number of cells, well, we have to do 3,500 grams divided by 2.7 times 10 to the negative 11 grams. So if I work out what this is equal to, I've got 3,500 divided by 2.7 times 10 to the negative 11. So I have 1.29629, etc. times 10 to the 14. So to 2 significant figures, I've got 1.30 times 10 to the 14. So we end up with 1.30 times 10 to the 14. Question 23. This map shows part of a village. Neil knows that Parker Street is 180 meters long in real life. Neil measures the map. He says Parker Street is 3.5 centimeters long and High Street is 11.2 centimeters long. Therefore, I calculate that High Street is 576 meters long in real life. Use Neil's figure to show that the answer to his calculation is correct. So, what we need to do is find the scale factor. So, for the scale factor, we need to find out how many times bigger the real life is to the map. So I've got 180 divided by 3.5, which is equal to 360 divided by 7. So for our scale, that will be given by 1 centimeter represents 360 divided by 7 meters. Now if he measures High Street to be 11.2 meters, that means High Street is equal to 11.2 multiplied by 360 over 7. So this is 576. So I have 576 meters in real life. So his calculation is correct. Part B, Geordie measures the same map. She says, I think Parker Street is longer than Neil's measurement of 3.5 centimeters. Therefore, High Street must be longer than 576 meters in real life. Is Geordie's reasoning correct? Show how you decide. Well, if the length on the map is more than 3.5 centimeters, for example 4 centimeters, then our scale factor is 180 divided by 4, which is 45. This means the scale is 1 centimeter represents 45 meters. So if I take this original 11.2 and multiply it by 45, 11.2 times 45 is 504. Now clearly this is less than the 576 meters, which means Geordie is incorrect. Part C. On another map, Parker Street is 2.4 centimeters long. Express the scale of this map in the form 1 to n. So, what we have is 2.4 centimeters equaling 180 meters. Let's put everything into centimeters. So I've got 2.4 centimeters, and if I multiply this by 100 to convert it into centimeters, I end up with 18,000 centimeters. And we want to represent this in the form 1 to n. So what I need to do now is divide both sides by 2.4. So if I divide both sides by 2.4, 18,000 divided by 2.4 is 7,500. So the ratio is 1 to 7,500. Question number 24. These graphs show different relationships between the variables x and y. Identify the graph which shows the following. Y is directly proportional to x. Well, here we require a straight line passing through the origin because we have something of the form y equals kx. So that is graph A. Then we have y is inversely proportional to x. Well, here we've got our graph being of the form y equals k over x, and that graph is graph C. Question 25. The diagram shows a square with 4 identical corners shaded. The length of each side of the square is 3x centimeters. The length of each shaded corner is x centimeters. We have to use this information to show that the shaded area to the unshaded area is 2/7. Show all your working. So first thing we can do is find out the area of one of these squares. So one square, we've got a half times base times height, so that's simply 1/2 x squared. And we've got 4 of these triangles, so the shaded area is 4 times by 1/2 x squared, which is 2x squared. So that's 4 of those triangles. Now we can also find the area of the square. The area of the square is 3x multiplied by 3x, which is 9x squared. So that's the area of the square. We can now find the unshaded area by subtracting the shaded area from the square. So the unshaded is 9x squared, subtract 2x squared, which is 7x squared. So the shaded to the unshaded, well, the shaded is given by 2x squared, and the unshaded is 7x squared. Now the x squareds cancel on the top and bottom, leaving us with 2/7.